Hello, everybody. Welcome to the lesson on metabolism, fact versus fiction. Okay, I'm just going to share my screen with you all. Okay, this lesson is something that it's a topic that I really like. It's something that is fascinating, and we do have to get into a little bit of science. We do have to cover, a little bit of a tricky topic, but in doing that, I think it would just really help you understand about what our metabolism actually is versus what it's not and what you can't do to it. And yeah, really just try and shed a little bit of light on this, because I feel like people try and dupe other people. So, your so-called fitness professionals will often use metabolic terminology and jargon to try and convince people that there's something wrong with their metabolism to buy their special product or to buy their special program. And I think that if you understand how metabolism works, you're less likely to be able to be fooled in this manner. So let's get started with this straight away. So basically, our metabolism is every chemical reaction that occurs inside of us to maintain life. Now, that's a fairly broad definition, and immediately you might go, okay, what does that actually mean? So we'll just break it down a little bit further. So it is every chemical reaction. So chemical reactions are occurring all the time, where substances are combining together, substances are being broken apart, substances are reacting with each other, and basically all of these reactions that are occurring are life sustaining. Now, as human beings, we know that we need certain things to live. We need oxygen, we need water, but we have four essential biomolecules or macromolecules. And these are our carbohydrates, fats, proteins, and nucleic acids. Now, you may not have heard of nucleic acids, but they are necessary for our DNA. Now, each of these macromolecules or biomolecules perform different functions. So we know that carbs, fats, and proteins play different roles in the body, and they're used for different things inside of the body. But we obtain these biomolecules from food. So when we consume food, the purpose of consuming food is to get carbs, proteins, fats, nucleic acids, so that we can then perform all of these necessary functions for life. However, the form that our food comes in, or the configuration that these fats, proteins, and carbohydrates come in, are not the right configuration for our body. So what we could think of is that the food that we eat is the wrong energy currency. We need to convert it to the right energy currency, and it also needs to be converted into a different structure. So basically what we do is we consume our food, we digest that food, so we break it down. And in breaking down that food, we actually free up energy. So inside of our food, all of the molecules, all of the small little units in there are joined together by bonds. And it is the bonds that's connecting all of these subunits together, all these molecules together. That's where all the energy is. So the energy is stored inside of those bonds. Now, when you eat food that is heavily processed, those bonds have already been partially broken down. So it doesn't take much for our body then to digest it. So we get a lot of energy from the food, and we expend very little energy breaking it down. So our net gain is quite high in terms of energy. Whereas when we eat unprocessed food, our body has to work substantially hard or harder to digest that food, and we have overall a lower net gain. So we have the energy from food, but then we're working quite hard, we're expending energy to digest that. So the net overall gain of energy is much lower in unprocessed food. Plus it comes with, all the nutrients that we need, our micronutrients. It comes with fiber, water, obviously our macronutrients. So it comes unprocessed food obviously is a whole lot better for us. But that's something else to consider, is that when we are digesting our food, if we don't have to work particularly hard to digest it, we're going to get a lot of energy or a greater net energy gain than if we have to work harder for it. So the energy is stored in those bonds. Now, part of our metabolic processes are involved in breaking down, and these are called catabolic processes. So we're breaking things down, that's catabolism. Now, then what happens is we've broken down our food, we've freed up a particular type of energy, which I'm going to talk about in a minute. And then what we have to do is we have to reassemble it again. So we have to reassemble it into our particular configuration that we need. So as an example, carbohydrates, most of them get broken down into glucose, but we don't store glucose in our body as glucose. It stays in our blood as glucose, but if it moves out of the blood and into our cells, it gets stored as glycogen, which is a different configuration. Our proteins get broken down into amino acids, and then we reassemble them into a particular structure, and that structure is very, very important, because if the structure isn't correct, then we don't get a functioning protein, and we might reassemble our proteins into, say, muscle tissue or bone, or it might become a functional protein like a hormone or an enzyme. So our metabolism is essentially the sum of our anabolic processes and our catabolic processes. So remembering that the catabolic frees up energy, whereas the anabolic requires energy. So really, metabolism is all about energy. It is all about the energy that is required to keep us going. Now, I need to talk about adenosine triphosphate. A little earlier, I just said that the food that we eat is the wrong energy currency. And what I mean is that we can't use carbohydrate, protein, and fat in that form for energy. We use something called adenosine triphosphate. If you were to go overseas, let's just say you go to England and you were to try and use your Australian dollars in England, you're not going to get very far. You need to convert your Aussie dollars into pound, pence, etc. So inside of our body, we have to do the same thing. We have to convert carbohydrate, protein, and fats into a usable form of energy. Now, we use kilos and kilos and kilos of adenosine triphosphate every day, and it's estimated at about 60, 70 kilos per day, depending on the person, obviously. So obviously, we can't store that kind of energy in our body. So what we do is we constantly recycle adenosine diphosphate and adenosine triphosphate. So what we have is we have these adenosine molecules floating around our body, just waiting for another phosphate molecule to come along. So I'm going to draw something on the whiteboard for you. So bear with me while I do this. Okay, so here we've got an adenosine with two phosphates. Now, it will eventually pick up a third phosphate and become adenosine triphosphate, TP, whereas that is ADP. So di meaning 2, tri meaning 3. Now, to get that extra phosphate to join on here, that is an energy in process. And this energy comes from, comes from food. Over here, where we knock off that third phosphate and it goes back to ADP, that is an energy out process. And that is what fuels our thinking, our movement, talking, writing, digestion, our heart. All the processes in our body occur because of this continual recycle process. But to be able to get adenosine diphosphate to become adenosine triphosphate, and this is the energy currency of the body, we need the energy that we take out of food to use to recombine ADP into ATP. And then once we knock off that third phosphate, remember all the energy is stored in the bonds. That energy is then used for all the processes in our body. And this is why you feel flat. You feel really tired when you don't eat enough food, because you don't have enough energy to sustain all of the ADP to ATP conversions that we need. So your body will just basically go, meh, I feel tired, and it will make you stop because it recognizes that this is being limited. So we need to eat a diet adequate in energy so that we can recombine ADP to ATP. And then our body knocks off that third phosphate, frees up that energy, and that enables us to talk and think and move and digest our food and for our heart to beat. Obviously, that's very important. Okay. So, oops, didn't mean to do that. So this is adenosine triphosphate and adenosine diphosphate. So this is just going around and around and around and around and around. It goes around continuously. It happens, probably trillions upon trillions of times each day. Now, this is where the anabolic and catabolic processes come in. So we have these complex molecules in our body. So glycogen, which is the stored version of glucose. So that gets stored in our muscles and our livers. Then you've got proteins, you've got triglycerides. Triglycerides are 3 fatty acids with a glycerol backbone. And what we do is we break that down. So this is a catabolic reaction. So we are releasing energy. And in releasing energy, what then happens is we get that ADP, adenosine diphosphate, and we are able to add that extra phosphate on. And so now what happens is we've got ATP, adenosine triphosphate. Now, then what we have is we've got these simple molecules, so glucose, amino acids, glycerol, fatty acids. What we're going to do is we're going to reconfigure them. We're going to reassemble them into something. So as an example, we might be taking these amino acids and we might be configuring them into a structural protein. So we might be rebuilding muscle tissue. So that is an anabolic reaction. So we're going to take the energy that comes from ATP as it gets converted back into ADP. Energy is released and we use that energy to undergo these anabolic reactions. So the catabolic reaction breaks down things into very small units that we can then reassemble, and we are using that ATP ADP conversion for energy so that we can reassemble these. Now, remembering that, so as an example, we've got these these complex molecules here. We might have them stored in our body already, but ultimately they come from our food. So if you don't eat enough food, you're going to run out of these things, and then you're going to struggle with the catabolic reactions. And eventually what happens is your body starts tapping into your own stores, which is great if you're trying to use your stored body fat. But if you, starve yourself for a long enough period of time, you're going to start tapping into your stored protein as well, which is, we don't technically store protein in our body, but our muscle tissue is like a pseudo storage system. And so you're going to start tapping into your muscle tissue. You'll start tapping into wherever the body can find protein. It will shrink your organs. It will take protein from wherever it needs to keep you alive.
The smallest subunit of proteins is called an amino acid, and our body breaks down all the different types of protein.
There we go. Okay. All righty. Beg your pardon for that. Now, when we look at catabolic reactions, as I said before, they're the breaking down. The best example or the easiest to understand catabolic reaction is when we eat our food and we digest it. As we break down those chemical bonds, or as we break down those bonds in the molecules in the food to free up energy, that is a catabolic reaction. And when we do break down food during digestion so that it can be used in these chemical reactions, that's called cellular respiration. So when we have cellular respiration, we're using glucose, we're using oxygen glucose and oxygen to make energy, the byproduct of water and carbon dioxide. So we're breathing out that carbon dioxide. We also lose or create water in that process. But cellular respiration is using glucose, it's using oxygen, and it gives us the products of ATP plus oxygen, plus carbon dioxide and water. So that's an example of a catabolic reaction. Now, anabolic reactions, or anabolism, is when we are building and assembling. And as I said before, the example of this is when we are, building our muscle tissue. So you go to the gym, you train your muscles, you create and stress and trauma in your muscle, and you need to fix this. And so it takes the food that we've eaten, particularly taking the protein that we've eaten, it breaks those proteins down into amino acids, and then it reassembles those amino acids into our own muscle tissue. Now, it's important to understand what influences metabolism. So there's a number of things. Mass determines your metabolism. So the more you weigh, the higher your metabolism. Now, these are obviously generalizations, but generally speaking, the more you weigh, the higher your metabolism. Lean body mass also influences our metabolic rate, and our lean body mass is bones, muscles, and organ mass. So we have lean body mass and fat-free mass. Our fat mass, or we've got lean body mass and fat mass, or instead of saying lean body mass, you could also call it fat-free mass. But fat mass is obviously our fatty tissue, and it does have an energy cost associated with it, but it's not as great an energy cost as our lean body mass. The more lean body mass you have, generally the higher your metabolism. Boys generally have a higher metabolism than girls, and that's mostly due to their higher muscle mass, but there is a hormonal influence as well. Age, as we get older, we tend to have a slower metabolism, but how much that is to do with age specifically rather than sedentary behavior is probably not well identified yet. Medical conditions, particularly thyroid-related conditions, these will have a significant impact on our metabolic pace because it is our thyroid that sets our metabolic pace. Genetics absolutely influences metabolism. So we do have fast and slow metabolisms, 100%. And we do have somatotypes, but it is important to recognize that these can still be influenced. Even if you find it hard to gain weight, you can gain weight. You can still put on muscle mass with the right nutrition and the right training program. And if you are overweight, you can control it. You'll have to work harder in these situations to change your body, but it's certainly not impossible. And diet. If you restrict a diet for too long, like if you severely energy restrict for too long, you absolutely will affect your metabolism. You will slow it down, and that happens under the effect of a number of hormones, but particularly our thyroid hormones. Okay, so the number one factor that affects our metabolism is our mass. So as you lose weight, and particularly if you lose substantial weight, you are absolutely going to slow your metabolism. So it's not a good idea to rate the effectiveness of a diet by how much it affected your metabolic pace, because if you did lose 50 or 60 kilos, your metabolism is going to be significantly affected by that because it is mass that is driving it. Now, when we do lose weight and our metabolism adjusts, that's called adaptive thermogenesis, and we know that it exists and we know why it happens, but we absolutely can lower the impact of this by weight training, improving our fitness, and then also eating adequate protein to protect our lean body mass. So as you lose weight, we want to make sure that if you do lose 50 or 60 kilos, you're losing 50 or 60 kilos of fat. And yes, your metabolism will slow down. And yes, you will eat less, but you should, because you now weigh 50 or 60 kilos less. So you should naturally be eating less, and you should naturally have a slower metabolism. So these are not necessarily bad things. And there's a lot of myth around this, people losing their minds over these adaptations to metabolism and saying, this person's metabolism is now in the ground. And it's like, well, no, it's not in the ground. It's just a lot slower than what it was before because they're a lot lighter than what they were before. So mass, number one, drives our metabolism. So I do hear and around that diet was terrible because their metabolism was so severely affected. It depends on how much you weigh as to how much your metabolism will be affected. You can't have a broken metabolism and still be alive. Same with faulty. You can't have a faulty metabolism and still be alive. If your metabolism is not working, we will know because you'll be dead. So that's the good news. In terms of foods that will speed up your metabolism, you might get a slight speeding up initially, and then it will be gone very quickly, and the effect is fairly negligible. We expend energy. Remember, metabolism is all about energy. We expend energy in three ways. Number one, our basal metabolic rate. In fact, I might share this on the whiteboard. Okay, so we expend energy, one, basal metabolic rate, 2, that's physical activity. 3, thermic effect of food. Okay, now our basal metabolic rate has got nothing to do with activity. I'll say movement, actually, just to be really clear. Sorry, I have issues with typing and talking. Nothing to do with movement. And it's about 60 to 70% of our total daily energy expenditure. So TDEE is total daily energy expenditure. Physical activity is all movement. Sorry. Including NEAT, which is non-exercise activity thermogenesis. So it's like fiddling, standing while you work. It's also structured and spontaneous activity. So it includes going to the gym, it includes, you know, running around after your kids, all that sort of stuff. Okay, and the physical activity is about 20 to 30% of TDEE. Now, the thermic effect of food, is the cost associated with digesting your food. Now, you can have foods that do have a higher cost, but the thermic effect of food is about 10% of TDEE. So if you are spending a lot of your time focusing in on the thermic effect of food, you're wasting your time. The most important things you could be looking at, number one, is your basal metabolic rate. Look at that, 60 to 70% of your total daily energy expenditure. Physical activity is only about 20 to 30%. So that's your next point of call. Trying to eat foods to speed up your metabolism, it's not a good strategy. And you're pretty much wasting your time, because any effect that you get is very subtle and it's reasonably transient. So you might get a slightly high calorie burn for a moment and then it'll be gone again. So the best way to impact upon the thermic effect of food is to eat food protein. Food protein has the highest cost associated with digestion. It costs the body about 25%. So let's just say you ate 100 calories of food protein. So I'm talking as in not liquid protein. So shakes doesn't have the same TDEE. But if you were to eat food protein, there's about a 25% cost associated with it. So if you ate 100 calories of, say, food protein, it would only give you a net total gain of 75 calories, because 25 of them would be lost in the digestive process. So protein is your best food for improving the thermic effect of food. All right, and then there's no such thing as starvation mode. People like to say that there is, but all that happens is if that you restrict your food for a long enough period of time, what your body does is it just slows down your metabolism and it starts tapping in to your protein stores, because you are eating insufficient protein. But it is all easily reversible with increasing your energy intake. So in terms of starvation mode, it doesn't exist. There's no research to support it. Okay. So how do we then care for your metabolism? And this is really important. If you really want to take care of your metabolism, and if you do find that your metabolism is a little sluggish, there's a few things that you need to be doing. Number one, you need to be weight training, whether you're doing body weight training or gym training. But you need to build muscle, you need to build your lean body mass, and weight training will do both of these. What weight training also does, it improves our hormone sensitivity, and that's really important. So you're going to see improvements in thyroid hormones, sensitivity. You're going to see improvements in insulin activity. You're going to see improvements in leptin and ghrelin, and these are our appetite hormones. So weight training is really important in that manner. In fact, exercise in general will do all these things in terms of hormone improvements. HIIT or cardio, really good at improving your cardiorespiratory fitness, and that just enables you to utilize stored energy more efficiently, which is a catabolic process. It also improves oxygen utilization and delivery throughout the body. It improves hormone signaling. So it's important to do a little bit of both from a metabolic consideration or metabolism perspective. You also want to be eating your protein to protect your lean body mass, and that's 1.6 to 2.2 grams per kilo per day. Now, you base that on your lean body mass if you know it. If you don't know what your lean body mass is, then you need to base this on your current weight if you are currently in a healthy weight range, or use your goal weight if you are overweight or obese. Another thing that is not considered enough is that you need to sleep. We need sleep for memory, for restoration, repair, for feeling normal, for feeling like we're not going to, go crazy at people. But sleep is necessary for optimal function. And we know that sleep restriction impairs our normal cortisol pulsatility. So cortisol is a hormone that it works in a 24-hour cycle. So what you'll find is that early in the morning, you'll start to see cortisol levels starting to rise, and it starts to rise because it wakes us up. At midnight, your cortisol level should be 0. So when people are producing too much cortisol, what they'll often find is they'll wake up at midnight or wake up in the middle of the night and they're wide awake and they don't know why. And what happens also is that if you get sleep restricted, rather than your cortisol levels dropping off, fairly rapidly, they remain elevated for a long period of time or prolonged period of time. And unfortunately, cortisol is catabolic. So you don't want this catabolic hormone circulating in your blood for longer than what it's meant to. So catabolic and anabolic are both very important, but they need to be in balance. So cortisol is a catabolic hormone, and it does obviously create problems when it's being produced in excess or if it's remaining in our system for too long. Sleep's also necessary for the production of growth hormone, testosterone, estrogen, and these are our anabolic hormones. So if you don't get enough sleep, they're not going to be produced properly. And then sleep also impairs the production of our thyroid hormone, and our thyroid hormone sets our metabolic pace. And we'll talk about thyroid in just a moment, but stress significantly impacts upon our thyroid function, and it can increase the production of something called reverse T3. So let's talk about the thyroid, because the thyroid is the endocrine gland that sets our metabolic pace. So it's really all about our metabolism. Now, we have a number of thyroid hormones. You've got thyroid stimulating hormone, you've got T4, T3, and then reverse T3. So T4 is an inactive form of the thyroid hormone. It's circulating around our body, waiting to get a signal to be converted into T3. You don't want active thyroid hormone raging around your body all the time. You would have some serious problems with that. So we have it circulating mostly as T4, and then what happens is your body signals it and it converts to T3. And the T3 is the active version of this hormone. And basically what it does is, okay, so I'm going to do a new share to show you something. Again, you're going to have to bear with me while everybody wants me today. While I draw this, so bear with me. Okay, so that is my cell. And on my cell, I have receptors. Now, hormones act like lock and keys. So here is my T3 hormone. So it binds to this side on the cell like a lock and key. Now, I have a number of these around my cell. And what happens is that my thyroid hormone will connect onto them, and in binding to these sites, it then is able to stimulate this cell to have these biological actions. All right, now what happens is in periods of stress, in periods of trauma, periods of dietary or energy stress or energy restriction, is we have something called reverse T3 binding to the cell. And what it will do is it will bind to all of the T3 sites, because it looks exactly the same and it's the same configuration as T3, but it does nothing. Now that makes sense. Sorry, that is a 3. It makes sense, doesn't it? So when you're not eating enough food, when you're in periods of stress, trauma, or illness, reverse T3 gets produced and it binds to these cells, and in doing that, it blocks the action of T3. Remember, what T3 does is it basically creates or stimulates the body to undergo metabolic processes, to go through all these chemical reactions that, you know, require energy. So what reverse T3 does is when it recognizes that there's a problem, is it binds to these sites and it stops T3 from binding to that site, and it slows down the metabolic pace. So it effectively, you know, slows your metabolism. Now, I might just save that. Just go back to my thingy. So we can actually have an increase in reverse T3 for a number of reasons, and I've got them listed here. And you can also have your thyroid stimulating hormone affected by a number of reasons as well. So we do have to be mindful that there are a number of things that can significantly impact upon, number one, our thyroid hormone being produced, and then also by causing an increase in this reverse T3, which slows down our metabolism. So what we want to consider is that, particularly as women, stress and trauma are really significant factors that impact upon our thyroid. So we do need to try and reduce our stress, try and deal with life events that are possibly traumatic as best as we can, because women are much more likely to develop autoimmune thyroid-related problems, so thyroiditis or Hashimoto's. And one of the key things for developing these autoimmune conditions, or one of the key factors, is stress or trauma. So if we go through a life event that is very, very stressful or very, very traumatic, we become increasingly susceptible to developing an autoimmune condition. And unfortunately, it can often be our thyroid. So there's a number of ways that we can obviously protect our thyroid. Number one, as I said, get enough sleep. Make sure you're dealing with your stress. And if you are going through a period that is quite difficult, you do need to consider whether you should seek professional assistance or professional help, see a psychologist or a counsellor. And if you're not currently exercising, obviously you should be using exercise as a means of managing your stress and helping you cope with the current situation. I have anxiety, and I've had anxiety since I had my twins, and I have found that one of the best ways of dealing with my anxiety has been exercise. It's helped 100% of the time. If I'm feeling really, really anxious and I go and do a little bit of high intensity cardio, I find that if I do, a HIIT session or high intensity cardio, even weights, all of it, it all works. It all makes me feel better immediately. But from a nutrient perspective, there's a number of things that we can, or a number of nutrients that we can eat that will protect our thyroid and help produce a healthy amount of our thyroid hormones. And then we've also got nutrients that will help with that conversion of inactive T4 to active T3. And then to make our cells more sensitive to thyroid hormones, we have some other nutrients and exercise. Exercise is so important for improving hormone sensitivity. Weight training, a little bit of cardio or HIIT, you're going to get a huge benefit from doing that. Now, from a thyroid perspective, it's really hard to go past seafood because a lot of the seafood is high in selenium, zinc, iron, iodine. Some of it's high in vitamin D as well. So these are all the foods that we really need to protect our thyroid and to keep our metabolism chugging along happily. All right, I hope that helped. I hope that all made sense. And if you've got any questions, please make sure you chuck them in the group. And I look forward to seeing you for the next lesson. All right, bye everybody.